All right. Hi, everyone. We are starting early. Uh, we hopefully others might join us later, but let's get into it. I've prepared three typical exercises that are in the second or in the uh, retake midterm. Hi. So yeah, I prepared three of them. One of them is like accidentally this year's second, but at least we can discuss it. And the other two is from last year, last year's retake. Yes. So you most likely will encounter them tomorrow, or like not exactly them, but a variation of it. The first one is like I've sent the task description in the chat, but basically, hi. Oh, it didn't. Never mind, then I will read it. So the first task description is a bank prepares statistics on how many transactions each customer makes via net bank, account numbers, a single integer, and the number of related transactions must be stored in a dynamic array sorted in ascending order by account number. There are no duplicate account numbers. The dynamic array is stored in a structure pointer plus the size of the dynamic array. The size of the occupied memory is always just right. And like first define the types belonging to the container, or like define the types which we are different data types that which we will be using. Write a function that searches for an account number and either returns where on what index it can be found, or if it can't be found, then signal it with an appropriate number. Write a function that receives a container and an account number as parameters, and registers a transaction, use the previous function to check if there is such an account number, in which case increase the number of transactions. If you don't already have such an account number, expand your storage by keeping it organized. In a short piece of code, create an empty container. So that was quite a lot of text, but what we can it's easier if you also see it. What we can decipher from it. First of all, we know that we will work with account numbers, a single integer, so integers, and connected to them is the number of related transactions. Now, because we know that an account number and the related transactions, which is also in int, it's like 1 or 2 or 3, something like that, is connected. Because of that, we need a structure where we can store the two of them together. And I have already done that here. I called this structure then we type def account, and every account stores a number, which is like the account number, and a transaction, which is the number of transactions this account has done. So the first part of the first exercise is if done, and the second is so both the account numbers and the related transactions, which now in a structure, must be stored in a dynamic array sorted in ascending order by account number. There are no duplicate account numbers. The dynamic array is stored in a structure plus pointer plus size. So we already have a structure for the account numbers and transactions. These are stored in an array, which is dynamically defined. So you use malloc, and you also need a different structure. Thanks to this sentence, the dynamic array is stored in a structure and pointer size. So we define a second structure. I called it BRK, but it could be anything. And inside this structure, we have an account type pointer, which I called data, and the size, which will be the size of our block of accounts. Now that we are done with the first one, which is like define the types belonging to the container. The second one, write a function that searches for an account number received as a parameter in the container in the container received as a parameter also. And as you can see, the return value should be the index of the found array element, indicate which suitable value if there is no result. Since the array is sorted, use binary search. So I already wrote it, so I will just explain it step by step, which line what it does. The first is like the header. It returns an integer. Why does it return an integer? Because we are looking for the index of of this element, the account number. So where we can find inside of the, I don't know, inside of the block. Obviously we call it where, and we add this parameter and this parameter. This is the list. This is where this BNK type parameter stores the pointer towards our list, or like our block, and obviously the size of the block, and this is the account number that we are looking for. The text said that we need to use binary search, which complicates a little bit, because if you don't need to use binary search, we could just use a for and our life would be much easier. But binary search is much faster. And also you have to remember that we can use binary search because we know that the block or like the array is sorted, and because it's sorted, we know where the account number should be if it's in the list, or like if it's in the array, we know where it should be. So we have to write an algorithm for binary search. Writing algorithm for binary search is basically always the same. First we define an int e, which will be 0. It will be the start of the array. A v. It will be we define an integer v, which will be the size of our array, and a k, it's like the middle, which is the middle of like the e, the v, e plus v divided by 2, so it will be exactly in the middle of it, and it will always be a whole number because it's like an integer, so it won't be, I don't know, 2.5 or some invalid value that we can't index. And now we use this while function, or like we use while loop, not function, sorry. While e is smaller than v, so like the two end of the array doesn't touch each other, aren't equal, or the end isn't smaller than the start, because otherwise it wouldn't be valid, or until we find our number. So bank pointing to data, because we need this arrow operator instead of a simple dot, because we used a pointer here, const pointer, and because of that we need this arrow operator. So inside the bank pointer pointing at data, which is like here, and it's an array, so in the data array the kth element number variable, which is like the account number of an account, isn't equal to the account number. So why this both of it is true, is true, we check if this number which is same as here. So like the kth account number in the array is smaller than the current account number. Now, if you know or if you remember how binary search works, then you know that binary search works by checking the middle element of an array, like exactly the middle or exactly the middle. If we found our element, then we are happy, of course. We can return. If not, we check if the current element is whether or not smaller or bigger than the number we are looking for. If it's smaller, then we know that our number will be on the from the right on the right side of the middle element. If it's smaller, yes, if it's smaller, we know that it will be on the left side. And depending on that, if it's smaller, if the middle element is smaller than the element we are looking for, we are taking only the upper half of the array by making e equals to the middle element plus 1. If it's bigger, so like this number is bigger than the account number, then we take the lower portion of this array by making v equal to k plus 1, and after obviously one of these will happen because it can't be equal, because if it's equal then it won't start this while loop. So one of these will happen. Both obviously can't happen, because a number can be bigger and smaller than another number at the same time. And then we shift the middle element between the start element and the end element. Instead of we could, because it's in Hungarian, meaning for eleje, vége, közepe, we could also say like this is the start, this is the end, this is the middle, and then start plus end if start smaller than end. Yes, start, middle, and middle, start, and we divide it by 2. We find the new middle element. We check if the new middle element is equal to the account number. If it's equal, then this while loop won't start. If it doesn't, then this while loop starts again. And it will go until we either find the number or get to the point where we know where the number should be. So we found either the now yes, we found one of its neighbor. We check where it should be, and we can't find it. If we can't find it, then if we can't find it, then we use this interesting piece of code. It's a short if. Let's say that it's like when there is only two option and not infinite, like here, no, not here, but like if it's only two option in a, it's a question that you can, it's a question where the answer is a yes or no and nothing else. Then you can use this code. What it does is basically, if the start is equal or bigger than the middle element, that means we didn't find the account number. So the account number is not yet in the in the data array. So we return with -1. Why -1? Because the exercise said this. Because the exercise said that we should return with a suitable value if if we can't find it, and -1 can never be an index in our array. Or if it's not true, then we return with k, which will be not k but middle, and it will be the index of the array. I can, yes, I will. I think I will open a new one and try to explain this binary search a bit more. So you have an array. Hi. So you have an array. Let's say 2, 4, 7, 10. I don't know, 12. As you can see, it's in not descending, but so it's in order. It's in order. And basically what we did in this piece of code, we choose a start and an end, and let's say we were looking for 10. So we want to find 10 in this array. We choose the middle element, which is like 0 plus 1, 2, 3, 4, 5. 5 times 2, that's 2.5. See, when you add 2.5 to an integer, it will take it as 2. So 0, 1, 2, it will take the middle element. Alright, now we make the comparison. Yeah, we will compare whether or not 7 is smaller than 10. Yes, because 7 is smaller than 10. Thanks to that. Because 7 is smaller than 10. Here. We move the start here. Because we know that our element will be in this upper portion, and we move the middle in the middle of the start and arrays, which will be here right now. 3, it will be 3. We move the middle element here, and we check if 10 is equal to 10, which is right. So we return with the middle elements index. So yeah, the first function has been done, and the second function is a function where we need to insert a transaction into the system. This function will return with void because it doesn't need any return value. It's not calculating something. It's changing an array, or like yes, changing an array. right now this data array. So we have the usual pointers, the bank pointer and a number, the account number that just done transaction, and we want obviously to increase the number of transactions. We create an integer called here, and we find the index of this account number by using the function that we just created, the var function, which returns the index of the account number, so like where you can find inside the array. And if it's not equal to -1, so it's any other number, which means it's we found it in the array. Then our job is easy. We add +1 to the transaction part of the structure, and then we return from the function. However, if we couldn't find it, then we need to dynamically allocate a new number of bits in the memory using malloc. So an account type pointer called new, casting account star, malloc, and how much we need to allocate is the size of the old array, which is stored in bank size, +1 with the new array that's coming in, because we couldn't find the account number inside the old array, so we need to insert it, so we need more space, times size of an account structure. We define an E and a J, both 0. This will be useful when copying the old array into the new one. So we use this while loop, while E is smaller than the size of like obviously we want to copy the whole old array into the new one, and the bank data point number in the at the E index was like yes. So basically the account number at the E index is smaller than the account number that we added as a variable. While this both of this is true, we add to the J to this add to this array the old array's data. Why do we need this end part? We need this end part because this list is what like array is sorted, and if we just put it at the end of it, we would ruin it. It's much easier if we put it in the right place, or like in its place where it should be. And this end close will make sure that we only putting the old data into the new database until it's smaller. Then we add the new data, which is like this account number +1 because it's its first transaction, and then we continue with the copying from the old list. Then we need to free the old array with free bank data, and make sure that bank data will be equal to the new pointer that we just created, which now contains the old list, the new account and the new account number, and it's sorted, and it's sorted. And obviously because we change the size of the array, we also need to add 1 to the size, and then we can return. And basically this is how you use it. You create a bank structure with uh, with a null pointer and 0 size. Should be inverted. Yes, null pointer and 0 size, and you use the insert. You gave it a, you write here basically an account number, and you write the structure or the variable's name here, and this is how you use it. So yeah, this was the first one. Dynamic memory allocation is usually in one of the exercises. The second one is a state machine. Yes, so it's a state machine. Basically, the task is to write a code which reads in from standard input until end of file or like end of stream. And if there is a word that ends with CS, then then it counts it, and at the end of the file it writes out how many words ended with C and S. For that you need to, and also for this exercise you also need to make a state machine, or like, yes, how it functions. I've already done the state machine, so I will show you in a second. So this is the state machine. The state machine is basically like a diagram or like a step-by-step machine that changes its state depending on where is it right now and what input it received. Obviously at the start it's like in the start position, and now with the and we are checking every character that input that's like that arrived into our program, or like that's on the input, and we go by character. We go character by character. So first we are at the start. Now here two things can happen. We receive C character in our input, or we receive not a C character at our input. If it's not at the state, that is not a C character, then it stays in the start state. If it's a C character, then it steps into what I call is, let's say, C state. So it's in the next state. Now, if in the states receives another input, it's a character. Now three things can happen. It could receive an S, which means it steps into the hash state. That's one option that can happen. The second, it's like obviously receives something else, and we need to make this difference between receiving a C and anything else. Because if it receives a C, then it needs to like point into itself. Because we are looking or like checking if we can find a CS at the end of the word. But if we are in the say C state and we get another C, so like C, C, S, and space, that's mean there is a CS at the end of the word. But if we didn't check for C, that it would jump into back to start, and then read the next one, it would be an S and Ash, and it wouldn't trigger, so we would miss one CS at the end of the word. So in case it's a C, it points into itself. It's the case it's anything else, it goes back to the start. And in case it's in case it's an Ash, it goes into Ash state. Now in Ash state, here's this state. There is also three options. It's a space after dash. Then we are happy because we found the word that ends with CS. So we add 1 plus 1 to the counter and go back to start. If it's a C again, then we go back to the C state, because CS space is also counts as 1. And for us to detect that, we need to like go back one state. And in case it's anything else, we go back to the start. Now, how does it look in like practice? I've implemented an integer CS count, I call it CS counter, and the structure an enum, call it state machine, and it has three states: start, letter C, and letter Ash. Obviously, you could use it, say like it's like integers, but it's much easier and more elegant this way. You declare a char, and also you create your state machine. Right now I call it A, and it should start in the start, obviously in the start state. And the task said that it should read in from standard input until end of file. It's like an expression. I added this part is end C equals O because otherwise it's really hard to shut the program off and test it. So when you are writing the midterm, you only need this piece of code, while C equals get char, and it doesn't, and the whole thing doesn't equal end of file. This while loop should go. I put it back. I need it back for testing. And now you implement the state machine. If we switch to the view switch, and we switch on the state of the state machine, basically, there is the first case where it's in start state. So here, and in this case, we only have one thing left to do: either step into C or do nothing. So if the character that we are receiving right now is C, the state should be letter C state, and break because switch case requires a break to jump out of like the function. Next, if it's letter C case, so here there is three way to go. if we are in this state and we get a letter ash, we jump to the letter ash state. Else, if we get another C, so we are in the letter C and we get another letter, we get the letter C, then we stay in this state, so like the letter C state. And if we get anything else, A, B, C, no C, A, B, D, anything, then we go back to the start, because we need to start the search all over again. If we are in the letter S case, then also three things can happen. We get a space after we get a space in this state. Then we are happy we found a word that ends with CS. So we add to the counter +1, and we jump back to the start state, because we can start our search again. If we get another C, like the letter S, then we jump back one state to the letter C state. And if we get anything else other than a space or a C, we go back to the start and we start our search again without any success. I added this default case, but it shouldn't be needed, just for, like, I don't know, better working program. And at the end of the whole file, or like the end of this whole while loop, we write out how many CS words we found. I will show it how it works in, like, actual practice. Will it run? Yes, thank you. I see. So now it should run. Yes. So like 1, 2, 3, 0 CS at the end of words. So yes, and if we run again, like 2, 3 C, 3 CS, and 3 CS. I messed up something. It worked before. Yeah, I know. It's because of the extra. So like, yeah, now it works. So yeah, 1 CS at the end of words. A state machine, or you can also imagine a state machine as, like, I don't know, slides, or like a dam, a series of dams, or like gates. And by that I mean, I don't know, we want to, there is 4 gates, or and we need to get through each of them to get to the end of the road. If we get like, we can either go through the gate if we achieved, or like, we successfully had our answers, we can go through the gate, or we can go back one gate, or we can go back to the start. But yeah, my experience is that we always had at least one of these kinds of exercises, and this one is, these state machines is kind of easy and 3 points if you understand how they work. And what I definitely suggest remembering is like this piece of code, while c, which is a char equals get char and it dot end of file, and then you need to write your state machine. These codes will be uploaded somewhere after it, so you can check it out. And the last one is like linked list type of exercise with prime numbers. Basically, we need to define a structure which can store a prime number and the power of it, and also the next item in the list. Yes. Also, we need to write a function that prints the prime numbers out, and a function that adds function that adds a new structure to the end of the linked list, and finally a function that can split a number up into prime number into the multiplication of multiple prime numbers. So let's get into it. First, we define the structure. I called it split because we are splitting, because yeah, it's part of a bigger number, but basically it has an integer, a prime integer, a power, the power integer, so like two integers, and a pointer to the next split stack. So the pointer to next split structure. So it's a linked list. I will use my trusty paint again, and basically like it's like yeah. So like this is one split structure that is like so prime power, and finally it's like I called it next, which is a pointer to the next split, which is basically like Control C, Control V, and that can like happen infinite number of times, and we know that it's over when the next is like a pointer to null. So this is the end of the linked list. This is how linked list is like it looks, or like how it works. And yeah, the exercise specifically requested is to work with linked list and not like, I don't know, an array or something like that. But back to the code. So we define the structure which supports linked lists. If you don't want to deal with them, it's I definitely suggest that at least learn this piece of code, because it definitely worth at least a point if you can like define the structure. And the first function for how to print out linked list or into using printf into the default output. Yes, let's call it that. So the return value is void because we don't want we are writing something to the screen, and we pass as a parameter the first element of the linked list, or its first element's pointer in the linked list, and we create an iterator which will go through go over this linked which we will go over this list, and we will use a for loop. The iterator should be equal to L, so like the start, go until the next until it finds a null value, and the iterator should always be pointing at pointing at the next value after this piece of code ran. And obviously, when it gets to the end of the list, it will receive a null value, like here, and because of that, it will no longer run and jump to the next line. So while this loop runs, it prints out the prime and the power from this structure to the standard output, and as you can see also here, if the next item isn't 0, or like isn't null, not 0, if it's in null, 0 and null is different, obviously, then it also prints an asterisk for because for aesthetics for aesthetic reasons. So overall, it will be something. It will look something like this. So let's say 3 to the power of 3 times 4 to the power of 5, and when it gets to the end of the list, or like the next item would be is the last, then it prints a \n, which is obviously new line, and then returns from the function. So one of the functions we written. The next one is like to add a new item at the end of this linked list. It returns a split pointer, which will be pointing to the first value of this array, and it needs a list, a new prime, and a new power. These will be obviously the values of the new element at the end of the list. So first we dynamically allocate memory, exactly the size of a split structure, using this code, obviously casting split, malloc size of split. This will give us exactly the needed amount of bytes. This new splits prime value should be equal to new prime, the power to the new power, and the next one should be null, because this will be the new end of the list, and obviously the end of the list is null, because that's how we know it's the last one in the list. And if the list we got is null, so like it doesn't contain any elements, then we just add. Then we just make the list equal to the new value. So the new will be the first element of the list and return that later. If the list that we passed as a parameter isn't empty, we use an iterator again to scream through all of the elements, just like last time. This is like iter equal to list, go until the iter next isn't equal null, iter equal iter next. So this piece of code will always go to a linked list up until the end of it. And basically it's empty because it doesn't need to do anything. And then we add the new element at the end of this list. And because we only moved the iterator and the list still pointing at the start of the list, we can return it. So with this technique, we can either create a new list, which is null, and add a new value to it and return that, or if it's not empty, then we can add the new value at the end of the list. And yeah, last final is like splitting. It returns a split structure, an integer, and we pass an integer as a parameter. We create a list that has no value at the moment, or like no nothing inside it, a divider, and we split this integer into like primes, multiplication. Obviously power is 0 when we start with power 0, and we do this while the n is bigger than 1, so it will always result in a series of numbers whose multiplication is the original number. If we found a number that can divide the original number, then we divide it as many times as we can. We increase the power here, and obviously if it was a divider that is bigger than 0, then we add it to the list, to the end of list, pressing the list as one variable, the divider and the power. We add plus one to the divider, and obviously it will run until it finds all the possible variations. And in the end it returns the list. And yeah, this is how you use it. You create a split structure with a number as a number pointer, and using this function it will split it up into the right numbers. And then with printer you can print it out. Yeah, basically. Uh, I also suggest looking at linked list and state machines before tomorrow's retake, because like 90% one of them is, well, 90%, I'm 90% sure at least one of them will be in tomorrow's test. Uh, yes. uh, I I prepared these exercises, honestly. I was a bit fast, but I hope I could at least help a little. Uh, both the code and the recording will be uploaded. And good luck tomorrow. Well, goodbye.